Okay, so question 3 says it has two parts, parts A and B. So question A is saying in an elastic collision, an object with momentum 25 kilograms meter per second collides with another object moving to the right that has momentum 35 kgs meter per second. After the collision, both objects are still moving to the right, but the first object's momentum changes to 10 kilograms meter per second. What is the final momentum of the second object? So we only have to analyze this question. This is also uh, a very, very good question. So in our analysis, they've given us the two momentum of the objects before, or the initial momentums, and they've also given us the final momentum of um, the first object here as 10 kg meter per second. So linear momentum, or how are we going to solve this question? So we're going to use the approach of conservation of momentum. And if we use the approach for conservation of momentum, that means initial momentum, which is P initial, should be equal to final momentum. And if that's what we have, that means we have momentum of object A. So we have momentum of A plus the momentum of B. This should be equal to, so these are initial. So this, let me put PI, okay. This should be equal to what? To the final momentum of A plus the final momentum of B, like that. So if we follow that approach, what are we going to see? We've been given the momentum of the first object there. This one, they've said the initial momentum is 25. This one, they've said the initial momentum is what? The initial momentum is 35. So if we have 25 kg meter per second here, then here we have kg meter per second, 35 kg meter per second as the initial momentums. We have to find the sum of those two values of our initial momentum. And if we add those two together, we're going to get what? We're going to get 60 kg meter per second as the initial combined momentum of the two objects. So if this is the combined initial momentum, let's also check the right-hand side of our equation where we have values for the final momentums of the two objects. So they've told us that the momentum for this object, the first object, the final momentum is 10 kg meter per second, like that. What does that mean? That means we can plug these things now into our equation. We're going to say 60 kg meter per second will be equal to what? It will be equal to 10 kg meter per second plus what we don't know. And what don't we know here? It is the momentum final of object B, like that. So we can just get this guy, take it to the other side of the equation. We're going to have 60 minus 10. This will be equal to the P final of our object P. So that means the momentum, or the final momentum of the second object, will be equal to what? It will be equal to 50 kgs meter second. So there is no change in momentum. That's why we used the formula for conservation of momentum. And if we plug in our values, we're going to find that the final momentum of the first object, or I mean the second object rather, should be 50 kg meters per second. Okay, so that is question A. That is question A. That is the momentum of the second object. Let's now check question B. Question B is saying a trolley of mass 0.8 kilograms collides head-on with a stationary trolley B at a velocity of 3.0 meters per second. Trolley B has twice the mass of trolley A. The trolleys stick together. Oh, the trolleys stick together. That's after collision, which means the collision is inelastic because there is sticking together taking place. So using the conservation of momentum, they're bringing back the idea of conservation of momentum. Calculate the common velocity of both trolleys after the collision. Determine whether this is an elastic or inelastic collision. Okay, so what are we going to do? Which approach are we going to use here? So we are also going to use the principle of what? Conservation of momentum. We're going to use conservation of linear momentum as usual. And what are we going to do? Let's bring down our formulas. Conservation of momentum means the initial momentum should be equal to the final momentum. So I'll say the initial momentum of A, we have two objects, plus the initial momentum of B, this is initial of B, should be equal to what? Should be equal to the final momentum. Since these two guys are sticking together, this should be equal to what? To P final. The final momentum of these guys, because they're going to have a common velocity. If they're sticking together, that means their final velocity should be common velocity. So for A, we're going to say mv for A, then mv for B. This should be equal to what? It should be equal to open bracket ma plus mb outside the brackets. We're going to have v final. Since they're sticking together, that means they'll have the common final velocity like that. So what is mv of the first object? Mass multiplied by velocity of the first object. So we've said the mass is 0.8 multiplied by the velocity, which is 3, plus what is the mass of B? They've told us to say the mass of B is actually twice the mass of A. So let me calculate this guy first. I'm going to find that the momentum of the first object is 2.4 kg meter per second, like that. Then what about trolley B? Trolley B was at rest, so which means whatever the mass is, if we say okay, the velocity, the mass is 1.6 kgs, the velocity of this object is 0. Why? It's because they said it was stationary, so that means it's a plus 0. So I'll say 1.6 kilograms multiplied by 0 meters per second, so which will still give me a 0, and this should be equal to what? This should be equal to these guys that are here on the right hand side. So what are we going to have on our right hand side? We're going to have the mass of A, which is 0.8, plus the mass of B, which is 1.6. This we're just multiplying 0.8 by 2, like that, multiplied by the V final there. We're looking for V final. So we're going to have, if we add these guys on the left hand side, we're going to have 2.4 kg meter per second being equal to what? Being equal to 0.8 plus 1.6. This is also going to give us 2.4 kilograms, and these kilograms are being multiplied by a V fine, like that. So we're going to divide both sides by 2.4 kilograms. Even this side, we divide by 2.4 kilograms. And what are we going to have? These guys should disappear, and our V final should be equal to what? This should be equal to the kg, and the kg will disappear there. Then I'm going to have 1 meter per second. So that is going to be the final velocity of these two guys. Since they are sticking together and they're having one common velocity, I'm sure you're going to understand that the collision is inelastic. All right, so that was question 3, both A and B. And until next time, make sure you like the video. You can comment your different ideas and also subscribe to the channel for much and many content like this. All right, thank you guys. Until next time.